Hi, everyone. I'm just going to go through the study guide that I put on Schoology here, just so you can kind of know how to use it. Unit 1, the big thing there is going to be socks with context. This is a guaranteed question that's going to be on there, this stuff right here. So be ready for it and take advantage of it. You can definitely get full credit on that just by identifying shape, center, spread, and outliers in one of those measures, and then using context frequently throughout. If you have two distributions, which is very possible, make sure you use comparative language, like saying one is greater than the other or equal to the other or something like that. Normal curve, remind yourself of how to use normal CDF. They will be looking for the z-score there. And if not the z-score, if you want to just stick to the calculator, you have to actually point to the values in normal CDF and write down what they mean. For example, pointing to the mu and saying mean, and pointing to the standard deviation, saying standard deviation, and so on. So that's that. Scatter plots and regression. I'm really not sure how much of this is going to be on there. Potentially nothing. But if you do have to interpret slope or intercept or correlation, here's kind of a guide to help you do all that. Samples and experimentation. This will certainly be on there. There will be some kind of question about one of these three bullet points here. Most likely the first one, which I kind of went into more detail down here, describing how to create a random sample. It's also possible that you could have a stratified and cluster situation. So here's a reference sheet to remind you what both of those types of sampling procedures are. Just remember to use context all the time with random samples and with the stratified and cluster, and also to be as specific as possible with what you do with the sampling. These require a few sentences. Don't be brief with this. Like, go into detail about how you would do each of those samples. Remember that if you describe stratified or cluster, you do need a random component for each of those. For stratified, within each group, you randomly select a proportional number of elements. And with cluster, you randomly select the place and survey every single values at those places. Okay, moving on to probability. My prediction is that it's going to be this guy right here, independent events. I think that is going to be the probability question. So proving they're independent by showing that if you have the probability of A, that is not impacted by B. More often than not, these problems end up being not independent. So you will probably find that probability of A is not equal to the probability of A given that B is occurring, which would mean they are not independent. And you would have to show that through the math. This over here is just kind of reminding you guys to, not be too lazy with the probability. Don't just put P of A. You have to use a little bit of context. You don't need full sentences for this, but you do need to define what A is. For example, if A is drawing a heart, write A equals drawing a heart. Binomial and geometric, possibly on there. Outside chance, I'd say probably not, but good to have it there in case you need to reference it. Moving on down to this part over here. I do think there's going to be a question which requires you to explain the conditions. So what I mean by that is they might say, like, the randomness condition is satisfied here. Why is that important? And you're going to have to be able to talk about how that creates a more representative sample with less bias in context of the problem. You'll also need to be ready to describe the 10% condition. Here's kind of a cookie cutter sentence for that, as well as the normal one. I would predict it will be the normal one, either the n times 1 minus p, the n is greater than or equal to 30, which would be central limit theorem, or the n is less than 30, in which case you would have to talk about how the distribution of sample means is still considered to be normally distributed if the box plot or dot plot does not show any significant skewness. Be sure whenever you describe this, you use the phrase distribution of sample blank. So it could be proportions, it means distribution of sample proportions, distribution of sample means, and so on. T or Z test, T test for means, Z for proportions. On a 2-question test, it's just going to be as straightforward as that. Not much more to think about there. But if you are asked about why it is a t-test, the answer is not about the sample size. The answer is that the population standard deviation is unknown. Here's a couple links to the formula page and the math symbols. Final page here, a little confidence interval reminder. These are the different point estimates that you would have for the 4 different confidence intervals you could create. And down here are some cookie cutter sentences about how you interpret confidence intervals, how you levels, how you make conclusions to tests, how you interpret a p-value. I would bet that this last part over here, interpreting a p-value, will be on there. So just be ready to have this sentence here. Assuming the null hypothesis is true, that it's a very important part. The phrase insert parameter here means that assuming the null hypothesis that 70% of AP Stats students studied the night before the test is true, something like that, that has the actual context of what you're testing in there. There is a blank percent chance of obtaining A, and this is where you actually put in what the statistic is, what the X bar is, what the difference in X bar is, what the P hat is, what the difference in P hat is, the actual number values there, and then finish it with or more extreme by chance alone. By chance alone is important there because we are talking about a probability on a normal curve centered at the null hypothesis. Now here's a review of the parameters. The big one I've been noticing on the things I've been looking at your work are these two right here. So matched pairs and 2 sample t. Matched pairs is average difference. 2 sample t is difference in average. So make sure that you use the right phrasing there. They will take off a pretty good proportion of the points if you put these words in the wrong direction. A type 1 error, rejecting the null even though the null is true. And a type 2 is the reverse, where you do not reject the null even though some alternative hypothesis was true, so you should have rejected it. Always include context. And as my final thought here, before I turn off the Screencastify, look at your document before you submit it. Make sure that every single problem has the context of the situation in it. Putting the context in each problem is going to be the thing that separates you from the score that you could get versus the one that you would get otherwise. So definitely go back, make sure you have context in every problem, and hope this helped.